Okay, so tonight, more proportions. Okay, the first night we talked about how to set up a proportion, build a proportion when we're looking at story problems. And then what we want to look at tonight is proportions. It's how they relate to line graphs and different kinds of tables and charts. So we're going to look at a few tables and charts. Some of these are familiar. We've probably seen them before, but we're going to ask you some different questions. All right, so for example, right off the bat, we're presented with this line graph, and the question is this graph proportional? All right, is it a proportional graph? And when we're asked this question, is a graph or is a chart proportional, we're either going to prove that yes it is by using a proportion, or we're going to prove no it's not by using a proportion. Okay, so regardless whether it's a yes or no answer, if we're asked to prove if something's proportional, then we should use a proportion to do so. Okay, so this graph, we're looking at it. So if it is proportional, we should be able to build a proportion. Okay, and as we go along, we're going to need some numbers. If we look, a lot of these points aren't working out too good. We'd have to estimate. Here's one. Okay, if we keep on going, a lot of these points are all approximations. We want to stay away from those as much as possible. There's another one here. Okay, so stay away from approximating. We have 10 to 18. So that can represent our first ratio, our coordinates. Okay, and then over here, 18, the next one would be 20, and we're going up 36. So we can build a proportion. Now remember, just building a proportion doesn't verify. Okay, we can put 4 numbers in here at random. All right, in order for it to be proportional, we got to check our cross products. If the cross products are good, they turn out equal, we're all right. 36 times 10, 360. 18 times 20, 360. So our products are equal. So we have a good proportion. So our line is a proportional graph. Okay? So now we got to be able to, that's the whole key today, is building proportions when we have a line graph or a chart. Right? We just got to find our values. Okay, same thing down here at the bottom. All right, if I give you a table and ask the question, is the table proportional? Okay, again, ignore these. All right, we just look at the table itself. Do we have a proportional chart? Yes or no? Well, again, same deal. If we want to prove if something's proportional, then our proportions, we should be able to build proportions. So 2 goes with 360. 6 goes with 1080. All right, again, just because I've thrown 4 numbers down there, that doesn't mean that it's proportional. We should check our cross products. Okay, so 1080 times 2, 2160. 360 times 6, 2160. Okay. Again, it's always good to verify. I know up here with this particular problem, we only built one proportion. We really only had one pair. We only had 2 pairs that actually worked out really nice on here. The rest of this would have been a lot of approximating for us to do. It's always a good idea. Please remember, in mathematics, we can always make something work one time. All right. So again, it's always a good idea to double check, to try another set. Can I build another proportion? Just because we built one proportion, in mathematics, we can always make one thing work one time. So it's always good to verify. Okay, if you would check this, you would get 14,400 here. you would get 14,400. So again, it works out. All right, so there's two proportions from one chart. So again, this would be, the answer to this question would be yes, and then we would say because, ... our proportions work. The new phrase of the day that we talked about, the constant of proportionality. Remember in class, synonym for the word rate. So when we're asked what the constant of proportionality is, all they're wanting us to decide is what's the rate for this particular graph. Okay, rates, remember, we want to compare something to 1. Okay, so according to this, we got people and days, and we got lots of choices here. So we can go here and here. So we got 24 people and 4 days. 24 people and 4 days. Again, that's not a rate, it's just a ratio. You have to get this down to 1 day. Divide by 4, divide by 4. We get 6 people per day. So now we have a rate. All right, or our constant of proportionality. So that's a phrase we're going to have to become comfortable with. And again, just a synonym for the word rate. All right, remember the last thing we introduced was our x and y axis. All right, how do we know if a line on here, okay, so there's line A, there's line B, there's line C, there's line D. Okay, which one of these 4 lines is proportional? To answer that question, we said in class, a line is proportional if it goes through the origin. The only line on this that I just drew that goes through the origin is line C. So this is the only proportional graph that we have. Okay, so looking at proportions in a little bit different aspect tonight, graphs and charts. Good luck, and as always, bring questions back to class tomorrow, and we'll answer any of them that you have. Thanks. Have a good night.